So those of you who are standing up, can you find your seats? Someone to the back of the room, can you close the doors? And yes, we are starting soon. So we are starting. Please find your seats. We have a very low number of participants this time. I think it's one of the reasons are that I think people are going to lunch. This is normal lunchtime, isn't it? What worries me a bit more is that I don't see some of the presenters, so I'm inclined to wait a couple of minutes. Can someone stick a head out of the door and I'll see if Adrian is there? We need him.
Adrian.
So while Stuart is doing that, this is the Mpls working group meeting in Prague, I think for the 4th time. And I actually think we've been in this room once before. So you have the note well. If you've been here the entire week, you have seen it a couple of times. Basically, remember that anything you say in the meeting or send a mail to the mailing list and things, those are contributions to the IETF and will be considered as such. If you haven't read the BCP 79, go and do that.
We can't hear you beyond 3 rows back.
Sorry?
Yeah, you need to eat the microphone.
I need to eat the microphone. Yeah. Okay. So we're ready to start. All the administrative information are the same as before. Please join us at Meet Echo and help people filling in the minutes so we get the right names to the right comment and the right comment and as understood by the one that made it. You have to add 3 to the Meet Echo link. 4. No, yeah, you have to add 3. 101 plus 3 is 104, yeah? Okay, thank you. You find the working group data tracker page is useful. Go and look at it now and then. Okay, next. So preparing this agenda has been a little bit of a roller coaster. We had 6 documents that people asked to present very early, and those 6 were actually removed. So now we have a little bit of elbow room in the agenda, and we can take time and discuss, and that should be okay. Wait, go back. So this is the proposed agenda. The TBD actually stands for Adrian. So he has to decide whether he wants to come up here, or he actually promised to do it.
Why my last name is in capital letters? It's not the usual way. In a good or bad way.
We're going to make that tradition, so you can live with it. I don't know. Ask Tarek. So anyone that want to bash the agenda? No? Okay, so we're going. Oh, that's what I did. The blue sheet should be started. Pass them on, fill them in, and when they get to the back of the room, bring them forward and try to capture if anyone actually come in and fill the spot. And return the blue sheets to the working group chairs. Okay. We have a number of erratas going on. Some of them are resolved, some of them are a bit dubious. One of them is actually a technical change. So you have the information here. You can read it. I don't want to go through the details. I think that Deborah actually handled one of them, so it should be out. I think it was NACT, the one that Deborah handled. But there are 4 more, and Deborah and the working group chairs need to discuss a bit what you want to do about them. Next slide. Yeah, still errata. Okay. We have a number of liaisons. My eyes are too bad. So one liaison is from study group 15 on the OTN work they're doing there. and they asked us for input on what we are doing. That liaison was actually sent today, so or actually maybe sent yesterday. Andy, did you actually get the PALS working group on that one, or?
Andy Mellis, to answer your question, Scott told me it would be included, but I have not yet seen the final version.
You can go and look at the, I don't think you were there, that's why I was asking. So we probably should send them a liaison telling that PALS is also there.
I'm gonna go to the liaisons page right now and take a look at it.
Yeah, okay.
Okay.
The others are being prepared. The last one, we don't need to respond, it's just for information. Okay, next one. Document status. Up till 5 meetings ago, we had at least one RFC per meeting cycle. For the last 4, we haven't had any. The good thing is now that we actually have documents in the RFC editors queue, and they should actually be progressed quite soon. I wonder, is Bruno in the room? Okay, the question I have for Bruno is about the misref and the status of that document. The misref is to a Spring document, the Mpls document in the Spring working group. And it has been misref for 345 days or something like that. But I hope it's moving. We have documents with the IESG, and they...
Just to answer your previous question, the PALS RFC is included, but the PALS working group chairs were not included in the signature. But as long as the RFC is in there, that's the important thing.
So you got halfway there.
Yes, exactly.
Okay. So what Andy is talking about, the liaison with Senate Study Group 15 did go from the working group chairs for 5 working groups. It's PCE, MPLS, CCAMP, TEAS, and PALS, though the PALS is not listed. And Adrian?
So Adrian, we're jumping around on
And that, we
on
are good at
items.
that. We can live with that. There's no problem.
So the misref, this is the one you're interested in, is the base SR MPLS
Yep.
document. Yeah, so that's completed its second working group last call. It had a working group last call, and it went through the process and got major revisions and went back. It's completed that last call. It's just at the moment waiting for the Shepherd write-up to move forward. But it's because it's already had quite a lot of review, it should be smooth from here on inwards.
So is the document Shepherd? Shadra?
I don't know.
Okay.
I could find out, but I have to walk
That's
over
not
there.
really that important, but we need to push a bit to get it done. It's actually, I think it's 6 other documents waiting for the same document also. As I said, the document with the ISG is going through the normal review processing.
I have an update on one of the drafts in that list.
Okay.
Draft IETF Mpls SFC encapsulation is now with the RFC editor. It's in the edit state.
That's true. When we did this 2 days ago, it wasn't like that. And then we have a new working group document. It's also on the agenda, but it's the RFC 8287, the length clarification. We have an ambition among the working group chairs and the authors to actually progress this pretty fast. So you expect a working group last call quite soon. Yep. And here are the list of documents that actually been updated since last time. And then we also have existing working group documents. The RMR extensions draft is actually just waiting for the base RMR draft to be progressed. I talked to Miguel about that one, and he promised that they were going to attend the updates quite as soon as possible. And I think I'm quite happy with that, so I will try to progress the RMR extensions. Come on.
Yes, Luis Contreras from Telefónica. So I'm the co-author of this draft, and that is our commitment to move forward as soon as possible.
Okay. Yep, you can jump one more slide. We also had a number of new individual documents. As you see, only 5 here, but some of them are in blue, and I think for those 5 documents, they were intended to, no, 4 of them were intended to be on the working group list and actually have been withdrawn. The one that's still there is the SPL terminology that Adrian will present soon. The RMR drafts here are also ready to be progressed, so there will be adoption polls and again within a few weeks. And those are drafts where the last 3 of those documents hasn't happened that much. The draft Shang Mpls RMR multicast, that is basically a framework. We talked about it a little bit in TEAS yesterday, and we are ready to start progressing it. You will see an IPR poll going out today or tomorrow. Draft Shang Mpls LSP Ping Yang configuration draft. Greg with capital letters will actually talk about it quite a bit, and since we have time, you can take your time there and try to explain what happens. Progress reports. Those are the base Yang and static Yang model. We have had further comments. The author says that everything has been addressed, and I believe them. So the next step is actually to start a Yang doctor review and the working group last call. Next. We're asking for status reports on the working group document, and we are missing some of them, but it's only 3 this time, so it's kind of acceptable. And I'm not really sure that I was expecting a status report on BFT directed, because that is with the shares and authors to actually try to find out what to do about it. So basically nothing to report. Here is my favorite list. So I listed all the drafts that I have in my mail folders that are not progressing. And my feeling is I removed the ones that people told me they are progressing somewhere else, or we have actually progressed them, or we're not going to do anything about it. I removed those. There are still 3 pages of drafts that I classify as Sleeping Beauty. Nothing really happens. I don't see anything happening about this draft. Yeah, so there are errors in this list. So tell me about the errors. There are duplicates in the list, so I will remove that. But I want help from people that has a draft that actually hasn't been progressed for a long time to actually say, no, I don't want to progress this anymore. Or if you want to progress it, tell me that you will do that. So now we kind of start looking at it.
So it's Adrian, I think a huge number of these are missing replaced by links in the data tracker. If you were to put these on a wiki page, then people can individually go in and edit. So if you put the column and what the right resolution should be, people can go and edit the resolutions, and that will be much easier for us to process than trying to work with email on such a long list, I think.
Okay. I think we have an Mpls working group wiki page, so I probably will use that one. Thank you.
Yeah, I want to echo the same thing. So one of the draft, the draft Kinney, which is about Spring Mpls LSP ping, that got merged with Kumar draft as Kumar Kinney, and now it is published as RFC 8287.
Okay, thank you. So, Andy.
While we're waiting for the presentation to come up, I'm Andy Malice. This is a short presentation on improving security for LDP. So if we could go to the next slide. Oh, great, thank you. There it is. So here's some history. LDP was first published back in 2001 as a proposed standard. It was replaced by RC 5036, which I think is still a draft standard, in October 2007. Both specified the use of TCP MD5 signature option for LDP authenticity and integrity checking for LDP messages to prevent against LDP message spoofing. As far back as 1998, the IETF was already aware of problems with MD5, and for example, you can see RFC 2385, for example, as an early RFC, which talks about the problems with MD5, and RFC 5925 back in 2010 deprecated the use of the TCP MD5 signature option, which is what LDP still is specified to use, and replaced it with the TCP authentication option, TCP AO. And basically that RFC describes the option itself. It does not talk about the actual cryptographic algorithms that you would use with the option. That's discussed in RFC 5926 to allow the cryptographic algorithms to be updated separately from the option itself. So in May 2013, RFC 6952 recommended that all TCP-based routing protocols move from MD5 to TCP AO. That would include LDP, as LDP runs over TCP. RFC 7454 in 2015 did that for BGP. So BGP has successfully moved over to TCP AO, at least in the specification, but it didn't actually choose a particular cryptographic algorithm to use with BGP. And as we know, LDP continues to specify the use of MD5. So what we want to be able to do is basically ask some questions of the working group. Come on, there we go. So the goal of this draft, and it was written by the co-chairs of Mpls and Mpls working groups, is to update LDP to replace MD5 with TCP AO. But the authors are really LDP experts, and we are not security experts. And so we have some questions to ask. First, we're asking here the MPLS working group, and then I'll be presenting this in the routing area working group as well, to have a larger discussion with the routing area working group as well. First of all, how successful has TCP/AO been for BGP? You know, because if it's not been successful for BGP, why bother doing this for LDP as well? Is it actually in use in the field? And if anyone can answer that question, please come on up to the mic. And then the question is, well, if we specify TCP/AO, then we have to choose a particular cryptographic algorithm to use with TCP/AO, and we would want one that works reasonably well in routers without basically, you know, slowing down the processing of LDP messages and so on. So we want something which is reasonably good in terms of the cryptographic properties, but something that doesn't degrade your performance either. And then the third question that we have, and then I'll start the line, is does anyone really care about this? I mean, is anyone even using MD5 currently with LDP? So with that, I'd like to start with Joel.
Joel Halpern with Ericsson. I'm certainly not anywhere near the BGP expert many people around here are. From the discussions I've seen, nobody's using TCP/AO on BGP. Conversely, attempting to put a draft through the IESG, which removed LDP MD5 and did not specify a replacement, would likely run into serious difficulty. So if we want to stop saying MD5 because frankly MD5 isn't a good idea, which it isn't, we probably need to say TCP/AO even if we doubt anybody's implementing either one.
Right, but of course our alternative is to just do nothing, right, and let things sit as they are.
Yeah, and that may be our best alternative.
And that's why we're asking the question in the first place.
Rajiv Asari, Cisco. I'm aware of at least 10 networks in the wild in production that actually use LDP with MD5. At least 10 that I could just name right away. There are perhaps more. So it is certainly a lot more commonly deployed than we would care for.
Cool.
Now, the
And-
question then I think you're really asking, would they care to replace MD5 with TCP/AO?
I was just about to ask you that question.
I was reading your mind. I don't know. And if I were to ask them, first question that I would need to have the answer for is it broken? I haven't seen any problem in my network with that yet. So unless we come up with a meaningful assertion that, yep, here are the challenges that you're going to run into if you haven't already. Well, oh, by the way, I should mention almost all of them probably have BGP with MD5 enabled as well. Thank you.
Great, thank you very much. That was very helpful.
Adrian Farrell, I think there's need to separate two things. The use of MD5 as a fat finger check and the use of MD5 as security. And there's a problem with security when you say we have never had a security breach, so we don't need secure security. Okay, nobody's ever robbed my house, so I don't need to lock the door. If we're going to have something we call security, it needs to be secure. MD5 is not. If we want something that checks configuration, fat fingers and things, then we should, and then MD5 is good enough, but we should mark it as such and say it is not secure.
So wait a minute, Rajiv and Adrian, are you saying that security for LDP is not really based on MD5? Misunderstand me correctly. I'm trying to ask, MD5 is there, in some networks, probably a lot of networks around, but it's not there because there is a strong security need there. It's used for checksums and other things.
So I can't answer whether people are using it and believe that they are getting security. I can answer that if they are using it because they believe they're getting security, then they are mistaken.
And I agree with Adrian 100%. So one of the things that might be useful to specify in the draft is, hey, if you are using MD5 to get the security construct with LD5, please consider moving away from it, and here's the alternative protocol. That would be very useful thing to do. And I'll send some text along that line.
Oh, that would be great. Thank you.
Deborah, speaking as AD, I'm very happy Adrian made the statement he did, because if there had been any security ADs in the room when we said, hey, nothing's ever happened, why we have to fix it, they would have been lined up at this mic in a flash. So what they want to see really is that we acknowledge that there are risks and that we definitely have a plan, a target to advise people using RFCs what they can do. And as they're saying, clarify, MD5 is not good for security. TCP/AO is a good target. And they will be more than happy to help us to fine tune if she use a crypto algorithm or what we should be saying there.
Okay, thanks.
But
So-
this is very important that we're doing this.
I agree. It's important. The thing I'm wondering about is really what are the threats, and are those threats remedied by MD5? Probably not. Are they remedied by TCP/AO? Maybe. But as long as we don't really have a good threat analysis, it's hard to actually say to give the correct recommendation.
Well, we have the one RFC from we had Mpls security considerations or something. Luann had done it and others. And I mean, it's also the security ADs are asking, are they out, maybe out in left field that they don't understand our threats and our use models? Have those use models changed? So they were actually asking for that type of information and to put it in the security considerations, that they don't have to every time go through it with a fine-tooth comb trying to figure out, well, how are we deploying this? So Laura, you're correct, and maybe we should update that document. Maybe in this document we should put a better analysis of what the threats could be, something
Yeah.
like that.
Just to point out, it was RFC 6952 that did that analysis.
Just 1 second. Are this draft is recalling use of the MD5, like don't use it, or just?
Yes. Well, the goal is basically to do exactly what RFC 7454 did with BGP. RFC 7454 for BGP said, stop using MD5, use TCP/AO instead, right? So the goal is to do basically the exact same thing for LDP.
So that means that whoever used the MD5 is out of spec now.
Well, no, not yet.
Yeah, well,
Right.
when we pass it,
Yes. Yeah.
when we publish it.
Yeah. When we publish it, if they want to be conformant to the new version of LDP that uses TCP/AO, then yes, they would need to update their implementation. Well, their vendor would need to update their code, and then they would need to deploy that in the field.
Okay.
Yeah.
So as a piece of anecdotal information was that when we actually put MD5 into the LDP, when we did the document the first time, We already know that there were doubts about MD5, and we made a note somewhere that you have to look into this. It only that we never had any indication that it was necessary. So that's why we are where we are.
Okay, so I think we're done. Okay, thanks.
Thank you, Andy. So next up is Adrian. So I circulate a list to be questions. So everyone has.
Sorry about that if you're listening remotely. That was me fiddling with the microphone. My name's TBD. I think on the original draft agenda, Loa put down 15 minutes for this draft, and I made the argument that we needed 30 seconds, so we'll compromise. It's a really small problem and a really small draft to solve it. The problem basically comes from when we wrote 7274, which was clarifying the use of special purpose labels, how you allocate them, how you retire them. We thought we had the terminology clear and consistent with the IANA registry. Since then, as people have started to write drafts that use, especially the extended special purpose labels, which are only just coming into use, we've found that people are a bit confused as to exactly what terminology they should use. So we've written this tiny little draft which tweaks the terminology, and the idea is then that we'll have something consistent we can use going forward, and we'll be stable at least for 6 months until we discover that this isn't clear either. So there are 2 registries that IANA maintains for this, and they are located on the same IANA web page. There are 2 ways into that web page. So when you go to the full list of registries, you see 2 entries separately, but whichever one you click on, it takes you to this page, and both registries are there. They are currently called Special Purpose MPLS Label Values and Extended Special Purpose MPLS Label Values, which all looks perfectly cool, but both of those registries contain label values that are special purpose. So now everyone is confused. When they say special purpose MPLS label, which registry are they really pointing at? So we propose to make this clear by further qualifying the base registry. So now both registries have a separate name, base and extended. So if you talk about special purpose, you're being generic. If you mean one registry, you say base. If you mean the other registry, you say extended. And that gives us then some shorthand terminologies. SPL, as I say, any special purpose label. A BSPL for the base, and one of those, of course, is the extension label. And then ESPL for all the extended special purpose labels. And remember, that's quite a big range, of which 0 to 15 you're not allowed to use, and the others are chopped out for allocation, experimentation, and something in the future maybe. And then we've added a new term to cover the pairing of the extension label and an extended special purpose label. So that's a composite special purpose label. I have said this so often now, my tongue is getting special purpose label. Julien, on this slide or in general?
Yes, but I can wait.
No.
Julien Maric, I was just wondering, does it mean that you can have extended base SPL from the second bullet when you use the extension label? I'm just wondering on how confusing the next stage of the terminology may end up into.
So you cannot, I think extended base would mean to have an extended base, you would have to have a base label with a value larger than 15. You cannot do that.
Okay.
Because the MPLS architecture, the reason we have extended labels, extended special purpose labels, is because you can't do that.
Okay, so it's just a
Because
matter of,
anything as a base label, anything that is larger than 15 is a real switching forwarding label. And any attempt to make a special reservation on that would blow up in all the deployed base. So we had to steal one label for the XL and make the extended.
okay, thank you.
Well, I'm all in favor of confusing the terminology if we can find a legitimate way to do it.
I can help you.
Well, yes. So what does that look like in use? This is the normal label stack with a what used to be just a regular SPL, but now we call it a base SPL showing up in the stack. Oh, it goes yellow. That's very nice. And this is what it looks if you have an extension label. Remember, the extension label is a base SPL, and then you follow that with an extended SPL, and the two of them together are called composite SPL. This is I mean, it's been on the mailing list, but oh wow, Meet Echo is like a week behind. Okay, right. It's been on the mailing list, but only for a week or something. It's really, really short. We would like to hear people tell us we got something wrong or we don't need to do it at all. Otherwise, it looks like it's so short that I would expect, well, I guess Loa can't do it, but I would expect the chairs to just like adopt and move through using their process and get it done quickly.
Questions? Okay, how many has actually read the draft? Fair number. How many think we should actually go ahead and do this? That is interesting, because that's more than actually read the draft. So you must have made a good presentation. Thank you. So thank you, Adrian.
Hello, everyone. My name is Quan Xiong from CT. My presentation today is the SR Mpls TP inter-domain use cases. First of all, let me explain the SR Mpls TP. As we all know that in SR Mpls networks, the SR path must be unidirectional. But in some transport networks, for example, the Mpls TP networks, the SR bidirectional path must be established. And the draft IETF Spring Mpls path segment, the draft has defined a path segment to support the SR bidirectional path correlation. So based on that, this document discusses the inter-domain scenarios in SR Mpls TP networks. In this document, the SR bidirectional end-to-end paths must be established across multiple domains. And the path segment is used to indicate the inter-domain path or the end-to-end path. So firstly, there are two models over the SR Mpls interdomain. The first one is the stitching interdomain. Domains are isolated and the stitching node or link will push the list of the SID to for the new subtuner. And in nesting interdomain model, global segments listed at the ingress load, SR load, and there is an end-to-end pass SID uniquely across all domains. And then in this document, we also discussed the SR Mpls TP interworking with the Mpls TP. This is achieved to realize the end-to-end VPN service by interworking between the SR and Mpls TP networks with the path segment. So first, let's look at the SR Mpls TP stitching into domain. There are 3 domains as the figure shown. In the stitching models, the end-to-end parts can be divided into several segments, and we defined an inter-domain path segment or inter-domain path SID to indicate each segment. For example, we will establish the end-to-end path from A to Z, and it will be divided into A to X, X to Y, and Y to Z. And there we have the I pass A to X, I pass X to Y, and I pass Y to Z. And this is the forward pass, and the reverse pass is the same. For example, the I pass Z to Y, Y to X, and X to A. So when we forward the packet at the ingress load, for example, in load A, we will push the first segment. For example, the A2X SRTE, it is the A2X SID list exactly, and the I pass A2X and the payload following that. Then, as we know, as our transit load will pop the top of the labels, and when the packets being forwarded to the load X, the I pass A2X will be the first will be the top label of the Mpls stacks. Then X will switch the I pass A to X to the next segment information, like this. I pass A to X will switch to the X to Y SRTE, and I pass X to Y. Then, at the load Y, it is the same with X. And when the packets being forwarded to the load Z, it will be only existed the I pass Y to Z, and then the I pass Y to Z will correlate the bidirectional parts. For example, the I pass Y to Z at the load Z will switch to the Z to Y SRTE and the Z to Y I pass ID. So this is the stitching into domain. Last thing into domain is there is an end-to-end path segment. We called it ePass A to Z to indicate the end-to-end path. And this is the forwarding path, and the reverse path is the Z to Y ePass. And this is at the ingress load A, we will push the A to X SRTE and the subpath A to X, and the bounding SID X to Y, and the bounding SID Y to Z, and finally we will push the E path A to Z. Then when the packet forwarded to the X, the top label will be the bounding SID X to Y, and the bounding SID we use it to reduce the depth over the Mpls label stack. So here is we use this to switch to bounding SID to the X to the domains SRTE, and its intra-domain path segment. For example, at the load X, the bounding SID X to Y, A to X will be switched to the X to Y SRTE and the S subpath X to Y. and at the load Y, it is the same procedure. And when the packet being forwarded to the load Z, there will be only the E parse A to Z existed. Then the Z will switch the A to Z E parse to the Z to A, the reverse parse segment. So the end-to-end E parse will correlate the two the unidirectional parse. So finally, we discussed the SR Mpls TP and the Mpls TP interworking. As the figure show, we have SR domain and Mpls TP domain, and they are the SR turner and Mpls turner. They are all the bidirectional turner, and we need to achieve the end-to-end VPN service across the SR and Mpls TP domains. Then we will use the path segment from load 1 to load A and stitching and associated the Mpls label at the load A. And this is the forwarding path. And in the reverse path at load A, we will mapping the Mpls label Z to A to the path segment from A to Z. Then we will achieve the end-to-end VPN service. So in this document, we discussed the several inter-domain use cases. So last step, we will search the solutions for SR Mpls TP inter-domain, and the comments and discussions are very welcome. Thank you.
Any questions? So I have one. I'm looking at the Spring Charter, and the Spring Charter says that SR typically works within one single trust domain. And then it goes on and makes some statement about some cases might be different. So this type of work is actually across what I understand are the trust domains. So Deborah, do you have a comment here? But Deborah, do you have an idea what we need? If we were to do this work, what would we have to do regarding the charter for Spring, or is there anything else we need to do?
You want to talk first?
Just one comment. Well, question is for Deborah. So Deborah has a mic.
I would say, without looking at the document, of course, to be very careful on the word domain and what that implies. And I do know that segment routing has been very careful in their definition of domain, because we went back and forth on that quite a bit in ISG. So I would say, just work with the chairs and of segment routing and just say, but as this is still just an very early document, I think just cross your T's and make sure you've defined domain as they do, and then that everybody can understand what it is that if you really mean intra-domain as regards segment routing, right? So just work, the chair, Loa, if you feel there's interest here to do this, work with the other chairs to see if there's a clash or whatever.
So,
and we can always CC their list, right, to say that we have this document.
Yeah, we will discuss it. I just kind of wanted the immediate reaction to point out that there is something that needs to be addressed here. I think that this document would probably need some discussion on the relationship between trust domains and the domains that you have in this document. For me, it's kind of reasonable to say that both the SR domain and the SR Mpls TP domain are within the same trust domain, but you need to define that clearly to get around later surprises when we go to, for example, ISG or directorate reviews.
Rafał Szarecki, Dreamer. When you say domain, right? Maybe that's a clarification of intention here. I didn't read the draft, sorry. You mean the administration domain or like IGP flooding domain?
I would actually say technology domain because that's
technology domain.
Yeah.
Because if it's SR, I need to assign the seats, right? So my first get was, okay, this is one big administration domain. So it's one operational organization. They just slice and dice internally for whatever reason.
Could be.
Joel Halpern again from Ericsson. Let me suggest looking at it slightly differently, getting at the point you were making, Loa. The point, as I understood the presentation, is to interwork between SR MPLS and conventional MPLS when you're doing path-sensitive information. Well, that's a perfectly valid thing to run into in a perfectly ordinary deployment scenario. I'm doing that over here, I'm doing the other over here. They're all part of the same domain. If you simply get rid of the notion that you're talking about interdomain, we now have a much simpler question that clearly does fall within our remit to address.
Thank you. Well, I think that is reasonable to look at it. My take is that the top of is trust or administrative domain. That's the big thing, and that could be sliced and diced in different ways internally. But then we are not really into domain. We are going across different technologies.
Domain is so vague. Right?
So anyone that want to write the terminology draft to me?
No. Okay, I was to say differently. Again, I understand Deborah's suggestion is to clarify how domain is used in the context of this proposal. So we don't have to boil the ocean and provide explanation of all possible interpretations, but just discuss and what we will agree on how we interpret domain in the context of this work. Yes, only this work, yes. And I take clue that been suggested, look carefully how domain is used throughout Spring documents and try to come up with what is most suitable for this work. So basically, try to reuse as much as possible interpretation that already being used in a Spring working group, specifically in SR-MPLS. And sorry, as one of co-authors, that's what we're gonna do.
Perfect. This is Adrian. Yeah, so I think what Spring did was they used a term called SR domain to mean an SR domain, and that enabled them to say that an SR domain has trust requirements, and also that SR does not leave that domain. That's actually the definition of an SR domain, that when an SR packet gets to the edge of the domain, it ceases to be SR. And if there's another SR domain, you have to restart. You can't get SR across. So looking at this document very briefly, there's just over 100 uses of the word domain in the document. It starts off talking about SR domain, but then I think it moves on to talking about different types of domain where the SR domain is big and within it there are different domains. So that's kind of
Yes, you're correct. There is this unintended change of terminology that might be explained, but at the same time, okay, so just to say, we have to be more disciplined with the terminology, and that's what we're going to do. We'll review the document. We appreciate your comments. Please do it on the mailing list and help us to make it better document. But yes, we'll need to clarify their mapping between SR domain and this use case.
Okay, any further questions? Can I see how many actually read the document? Oh, I see. Well, that must be two authors. There's one or two or three hands. Yeah, now the two. Okay. Okay, thank you. You have some ideas that what should be done, and go ahead and do that and post a new version of the document on the mailing list.
Okay, thank you.
Okay. So now it's Greg. Did you steal the? There.
Okay, so as Laura already announced, this is just an update. You might recall that we have a working group adoption poll.
Greg, I should do some of the background first. We started the working group working group adoption poll on this document. We found that there are things to discuss, so we don't normally want to take that type of discussion, especially if we aim to do an update during a working group adoption poll. So I closed the working group adoption poll. I told Greg to go and talk to the people making comments and actually try to post a new version of the document, and then we restart the working group adoption poll later.
Mm-hmm. Yes. So as part of their Mpls working group process before adoption poll, Mpls review team experts were asked and volunteered to review. We receive reviews from AC and Rakesh. Many thanks to them. And as we discussed their comments, some of the comments got addressed in a document that been published in the course of this as a result of discussion. But some comments we agreed with AC and Rakesh that would be certainly addressed in the following work, and that can happen after working group adoption. As we received, as the working group adoption poll was officially opened, we received comments from Tom, and it was absolutely appropriate comments, and I accept all of them. But we couldn't communicate fast enough to separate the comments that he believes that needs to be addressed before document adopted by the working group, and then can be worked later on. So that's exactly what we're doing now. I shared this slides with Tom, and so here there are issues that's still outstanding, and these are a combination of issues that have been pointed out both by Tom and AC and Rakesh. Specifically, what Tom is pointing to is that lack of references in the model makes it very hard to map it. In part, this is because this draft, this model has a very long history. So it started as 4379 model, and then 8029 updated LSP, MPLS LSP ping RFC came out. So now we believe that it should be pointing to 8029. And there are a lot of things that we need to catch up. And we will certainly do that. And we hope that the working group will participate and contribute once it takes ownership of this document. So waiting for Tom to respond on his opinion, what he thinks as a mandatory changes before another working group adoption, and what with our agreement and commitment to follow through all the comments that we received so far, what he agrees that would be acceptable to address after working group adoption. And so that's priorities for work that possibly after working group adoption, but it might change based on Tom input. And the last one, it expands scope beyond 8029. It was pointed as optional by AC and Rakesh because, yes, there have been several extensions to Mpls LSP to other cases like point-to-multipoint LSP, EVPN, Spring. So we'll definitely need working group input and suggestions where you think that everything better be put into one model, or these new extensions to MPLS LSP ping can be worked as augmentation.
But any questions? I have one, and I asked you before. When you have RSVP, or actually RSVP-TE in the same sentence as a FEC, that's problematic because there's no way of doing FEC validation or FEC signaling in RSVP.
Well, if I remember correctly, that's the terminology used in 4379 and then consecutively in 8029. So, but I'll take another look at the terminologies used because again, the TLV is called target FEC TLV. So it might be that it's more like a lingo that we're talking about as this is a FEC, whereas, yeah, it might be not really a FEC, but it's basically we're describing for which LSP this label was allocated, and that's we're verifying that this LSP echo request arrived on an LSP that this label been allocated for. So basically, one of their main OEM goals that LSP ping achieves is to verify their consistency between the control plane and the data plane, so that their endpoint receives their LSP ping from the echo request from their LSP that the label been assigned for. So basically, there is a correlation between the control plane when the label was assigned to the data plane status where this echo request arrived from.
So what you're saying is that your first sentence there should be reference to RC 8029 in the existing target FEC TLV.
Mm-hmm.
Okay.
Yeah.
Anyone that actually know if the target FEC TLV is defined for RSVP?
Yeah, and again, it could be lingo, but yes, it's called RSVP, not RSVPT. And that's, I believe, how it's recorded in IANA registry, RSVP.
Tarek from Cisco. Yeah, the LSP FAC, the 5-tuple, basically. It's defined in, I believe, RFC 3209. It is carried in the OEM packet as a target FAC. Is that what you intend? Is that your model trying to? Yeah.
No, I think that, again, Tarek, the question is whether the RSVP FAC is a correct or is it accurate name, or should it be RSVPT FAC?
Right. I think it's enough identification to identify that LSP or that label. That
right.
And there's 5 items there that at least we're trying to model in the RSVPT model. We're using 5-tuple to identify that LSP, if that's what you mean.
Nagendra from Cisco. In 8029, we have it defined as RSVP, IPv4 LSP, and IPv6 LSP, the differentiates between different address family.
Yeah, right. But again, if I understand your question correctly, is that should it be RSVPT, IPv4, IPv6 FAC? Yeah, but my understanding is that for one reason or another, in IANA, it's recorded as RSVP, IPv4, IPv6 FAC.
This might be mode. I need to go check it again, but there might be a couple of words that need to go in there to make it clear.
Okay, sure.
Yeah, I think, I mean, again, it's like LDP IPv4 and RSVP IPv4. So it basically uses the protocol that we use to instantiate the LSP path. So I'm not too sure if we really need to define if it is for traffic engineering, because I'm not aware of any other application of RSVP to instantiate the LSPs.
Okay, further questions? Okay, thank you, Greg. And who is next? It's Kumar.
This is Nagendra from Cisco. This is a draft that clarifies the length for the sub-TLVs that is defined in RFC 8287. This was identified as part of interop testing with EANTC. So RFC 8287 basically defines the the targeted FEC stack sub-TLV for segment routing, IGP prefix SID, and adjacency SID. So one of the thing that was missed in RFC 8287 is to clarify if or how the length of the sub-TLVs should be computed. So this is an example of one of the targeted FEC stack sub-TLV, which is for IGP prefix segment ID. So as you could see, one of the field is a reserved field. There are implementation where some implementation considers the reserved field as part of the length while defining the TLV, where another implementation does not include this, which basically created some interop issue. So this draft basically clarifies that to address those interop issues. So we basically defined that the reserved field must be considered while computing the length field. So it explains the different sub-TLVs and identifies what would be the length along with a couple of examples. So it's a pretty straightforward and a simple draft that basically we believe is a surgical fix for one of the interop problem. Like Kalo was mentioning, I know this was recently adopted as a workgroup document, and this being a straightforward fix, we believe this is ready for workgroup loss call. But any comments or feedbacks are welcome.
Okay, thank you. One point that is more for a procedure. You actually need to send a request for a working group last call to the working group chairs. It's more for our bookkeeping than for anything else, but it makes it easier.
Hi, this is Zhe Chen from Huawei, and this is a new draft named LSP data plan for cyclic queuing and forwarding or bounded latency. So let's begin with the background of this large-scale deterministic network, which we are doing in the DataNet working group. And LDN aims to achieve bounded latency forwarding on layer 3 networks and contain long distance links and large numbers of nodes and flows. And LDN requires that all packets sent from the upstream router in a specific cycle must be sent to the downstream router within another specific cycle, because in LDN, we maintain 3 queues in a specific interface, and those queues are cyclic scheduled. Therefore, in LDN, it requires that a data plan mechanism is used to indicate which upstream node cycle a packet belongs to, so that a downstream node could use this indication to put the packet into the right receiving queue. So if we consider a specific package, once the cycle for the sending packet in the ingress node is determined, the one in the egress node is determined too, thus achieving end-to-end bounded latency. So this is the LSP data plan for CQF. The idea is very simple. The downstream node allocates 3 different Mpls labels for each LSP and advertises information to the upstream node by using signaling protocols such as SVPTE. So each of these labels is associated with a specific queue in the upstream node. As shown in the right figure, we assume that if the packet is sent from the upstream node Q1, it should be labeled with 1003. And if the packet is sent from the Q2, it should be labeled with 1001. So about the FIP installation, we assume that packets sent from the upstream node Q1, Q2, and Q3 should be put into the downstream nodes Q3, Q1, and Q2 respectively. Note that how to establish such mapping relationship will be described in the future version of this document. And therefore, the package sent from downstream node Q1 will be put into the downstream node Q3, so on and so forth. So in this way, the end-to-end bounded latency could be achieved as per the LDN draft. So next steps about this draft, we will describe how to establish the mapping relationship. We have a self-learning mechanism in the data plan, and we need more suggestions and comments on this new work. Thanks.
Rajiv Asari, Cisco. So does the draft also specify how the mapping, or how the upstream neighbor would learn about the distinct labels for the same prefix but differentiated by the queues or the class of services to the upstream neighbor?
Currently, our solution is that it doesn't matter which label the upstream node associate it to a specific queue, because we have a self-learning mechanism in the downstream node to learn this information. For example, if I receive a packet labeled with 1001 in the downstream node, it can automatically send this packet in a specific queue in a local computation.
Okay, then I'm at a loss. If the node 1 is sending the packet with one label,
okay,
1001 to node 2, node 2 locally is somehow changing 1001 into 1002, 1003, 1004, depending on the queues internally.
Yeah.
If I
right.
follow that right, then
Yeah, that's right.
then it's local to the node. Then why does it need to be, or does it not need to be conveyed to the external set of neighbors like node 1? And if there's no need, then
Because the downstream node must know that a group of packets belongs to a cycle in the upstream node, and another group of packets belongs to another cycle in the upstream node. So that's why we should use 3 labels to identify this information.
but is that supposed to be the internal to the node, or it's supposed to be external to the node, the usage of distinct labels per queue?
It's just the local information in the downstream node.
So Rajiv, can I try to, clarify, at least for me, your question? So sending a packet to a node, does that have a specific label depending on which queue it should go into? That's what you mean with external? Or is it just inside the node, and when it comes out again on the outgoing interface, it has
Just
one single label for?
Right, so indeed. So are we intending to specify the internal node specific local behavior? Or we are specifying something that changes either the data plane on the wire or the control plane on the wire, or both? And that's what I'm struggling with. So
Okay, maybe I can clarify this with an example in the data plane. If the downstream node receives a packet, this is the first packet from this upstream node it received, and this label is 1001, and it will, if it receives this packet in cycle X, so it will map this label to cycle X plus 2. So it will establish the mapping relationship that which label should be mapped to which queue, and use this mapping relationship to instruct the subsequent packet. So it's just a local computation procedure.
and if it's a local computation and behavior change, I mean, most implementations today do something similar from the queuing point of view by looking at Mpls TC bits as an example, of previously known as EXP, and then whatever the value might be, they map it to one of those many queues that the implementation of the platform may have. That's all in local behavior, right? I mean, we don't really specify how that gets done internal inside the implementation. So if the intent of the draft is to specify what the implementation might intend to do to map an incoming packet to one of many queues, then I'm not sure if that needs to be standardized.
Okay, so maybe I can describe the details in the data plan in the future version of this document, and then we can talk about more about it.
Sure, yeah, and maybe we can talk offline as well.
Okay, thank you.
Actually, Greg Mirsky, ZT, especially for the DetNet, even if it's a local behavior, I think that might be helpful and useful to do the document that explains it, because there are a lot of needs to be required coordination, and everything has to act in accord in order to achieve their objectives of DetNet. So yes, it might look like it's local matter in implementation, but it might be important, and let's look at this more, because it might be just need to be advertised as capability.
Thank you.
Janos Farkas, I have a question for clarification first. The title mentions CQF, cyclic queuing and forwarding, and the first slide refers to the so-called large scale. I'm confused what it is about. The cyclic queuing forwarding is the IEEE standard 802.1 QC H that is rolled into 802.1 Q 2018.
I'm sorry, it's kind of misleading because this draft is targets the large scale network deterministic networking, and LDN use and somehow enhanced CQF to achieve the bounded latency. So maybe the terms is not correct.
I think that's a different approach, so it's misleading to use CQF.
Okay.
And for that, I would like to mention just the previous session in this room in that there was a lengthy discussion on the basic proposal you referred to, and it's not clear what's the next step forward and what the next step we are taking, what is needed. It has been shown that the mathematical proof is incorrect, so it's open what's happening in that net and what would be the next steps.
Okay, thank you.
Further questions? Can I ask how many actually read the document? Like 3, 4, okay. There are clarifications that we are asking for, as you understood, so please go ahead and do those and post a new version. Okay, thank you. And now we have that can be done. Someone knows. We are performance management encapsulation. Yeah. Oh, you have. Okay, so let's do the mean draft first, and then we will get you.
It's a long document on the data tracker.
That's correct. Yeah. So we're swapping the last two presentations because we have a error in the data tracking.
Jay Kumar, Broadcom. Before I go in this drafts discussion, I'll talk about the background of the draft, that how it came into the existence. So there was a work which was done for customers in the IP network where they wanted to collect the data on a live packet, which as we call as in-band network telemetry. That work is being deployed into large MSTCs. Quite a few deployments are there, and that's in V4, TCP, UDP, GRE, IP and IP, AH, ESP. It's a pretty large NCAP set which is being deployed. So once that deployment was done, the requests were coming that can we do the same thing into MPLS? And then based on that, the evolution of this draft happened, which is in-band network telemetry in MPLS domain, and hence the acronym MINT. Greg, you are there. Before I go, you have a question?
Okay, I can wait. I just want to point that we had the discussion when original proposal for IOEM as in-band OEM came around, and I think it's not accurate and it's misleading, because in-band means that OEM packet follows the data packet, and active OEM can be in-band, and actually if it's not in-band, then the value of this active OEM is very limited. So in particular in MPLS and ECMP environment, if the entropy label is used to generate the hash in ECMP, then active OEM is as much as in-band as anything else. So that's why I think that try to highlight and differentiate that saying, oh, this is in-band, implying that everything else is not in-band, is not technically accurate.
Okay, so I'm not aware of that discussion. So the reason I have used in-band is because the goal is that the OEM packet, as you're calling, or the mint packet, as we call in the draft, must traverse the same data path in the data plane. Right?
And in MPLS, if we're talking about active, either it's BFD or MPLS LSP ping, so if we be disciplined and use entropy label on data flow and active OEM that's supposed to monitor the data flow, then they are in band. Because in band, again, my interpretation is that you follow exactly the same path, same nodes, interfaces, and links. So use of entropy label and the same label encapsulation, and it's applicable both to MPLS and SR-MPLS.
I see your point. I get it. Yeah, I agree with that. So if you use the entropy label in the LSP ping, then it can also follow the same path. So if there is a suggestion to change the name, we are open to that. It's a first draft. So coming back to the draft. So as I was giving the background, this has been deployed in IP networks. There are conversations for deploying in the MPLS network. I don't know if I'll be able to go in all the details, but the key point is the usage of the special label, the composite special label, as was talked earlier. This draft makes use of that. I don't know if it's the first draft to make use of it, but I realize there are authors on this draft and the other SPL draft, which are common, so that's why probably the lean to use this, or the suggestion to use the CSP. So motivation is again that the protocol itself should be very simple. It should be in band, and we should be able to trace the flow of the packet, which is exactly same as the original live packet flow. There are few enhancements which we can do in this, which is captured in the details, which is a clone mode or in-band mode. In-band mode meaning that all the data which is being collected by inserting the metadata in the packet itself is done for the live packets. And there is a clone mode where we make a copy of the packet, and that can be done for various reasons, because the MTU, the PMTU is less, the packet may exceed the PMTU, or there are other reasons to do that. In that case, there is the ability to create a cloning of the packet, and then the in-band collection of the data is done for the clone mode. Great.
Okay. There are at least two proposals, or if not actually three, in IPPM working group. In no particular order. One of them in flow analyzer, IFA. Another one is postcard, and another one is hybrid two-step. They are not data plane specific. At least IFA does have or defines a use of cloning method to obtain. Actually, I personally prefer for this type of telemetry collection as on-path telemetry connection, similar to on-path support. Hybrid two-step proposes to collection of data in a follow-up packet that has the same transport layer encapsulation as a data packet. So the data packet effectively is only a trigger, and all telemetry information is in a follow-up wagon. And actually the HTC defines that if this packet is full, then another packet can be generated. So basically we'll arrive with a train of telemetry information filled packets. And postcard is that when telemetry is exported off each node that traversed by the trigger packet.
Right. So thank you for that. So I can give a brief background on that conversation which Greg just talked about. So if you look carefully, there are three parts to the proposal, and these proposals are also moving in the IPPM group. There is a protocol and cap part, especially in the IP. Then there is a data header part, that how do you represent the data in a way where you can figure out either the checksum of the data, the length of the data, or put some control information, and then the data itself. So there are various proposals for the packet and cap. I agree. And this is a proposal which is very, very simple in the IP, and it's deployed. So we have a proof point that it works, right? I'm talking to various folks in IOM where we can have some agreement on the data header as well as the data types. So data types become a registry, and then based on the registry, we can define namespaces, which is essentially the set of data types which uses a common data header, and then they can be carried over in different protocols. Protocols could be a postcard, could be IOM, could be IFA, so on and so forth. And the same proposal follows here. In this case, the protocol becomes very simple because protocol and cap is done using the CSP. This is just use cases that a set of use cases, and they are very basic. There are advanced use cases which can be built on that. This is just a summary of those use cases. This is the terminology, the way we have defined, and I believe based on the input, if MINT or in-band network telemetry is not the right acronym, then we have to change the labels. So I'm okay with that. But just to give you an idea, what essentially it says that MINT is a domain where all the nodes are participating in MINT, essentially collecting the data on a per packet basis. The node in a domain is called as a MINT node, and the MINT label, which is the CSP, which is the extended label using the label extension 15, is allocated. In the draft, we have taken a liberty to use the first label, which is 16, since nothing was used so far, but that's just an attempt. If that's not the right thing, we can always change that. MINT metadata is the information, or is the data set which is collected on a per node per packet basis. There are functions on the node, and these are the functions which either sit on the edge of the domain or sit within the middle of the domain. The edge of the domain is defined by the node which performs the initiation function or the termination function. Initiation means that when the packet comes in, there is an insertion of MINT header and also the MINT metadata by that node. And then the transit nodes, all they do the detection part that, yes, this is a MINT packet. It has a presence of the CSP label. And then based on that, it inserts the metadata at some predefined location. And then the last node at the edge, which is the termination node, does the same thing, that it detects that it's a MINT packet. And then based on if it's a copy of the packet, then it drops it. If it's a live packet or in-band packet, then it strips the foreign data, creates a report, and report could be anything. It could be postcard, for example, and then sends it out to the collector. So that's the domain and the nodes and the functions. This is the terminology which is used in the draft throughout, right?
I wonder if you consider it instead of using label to indicate, use just associated channel type.
So in the draft, we have not put the appendix of all the considerations. There is an issue with that, and I can have a side conversation with using the ASH. Actually, we'll capture it in the draft, that what are the other options which we'll consider.
Right, because again, in 1588 propagation over MPLS, so in this RFC residence time measurement, we proposed to transport 1588 through the domain is associated channel new type, and then collect on each node residence time in the scratch field. And that can be used not only, it can be used either to measure residence time across the path, or it can be used as well for correction of 1588 clock. So from the master to the slave. And actually, there is a description of how you can manipulate TTL on a label, because you can discover which nodes participate in it. So then not every node can be compliant. The problem with their label might happen in SR-MPLS, because you might then have to insert this label multiple times based on what their maximum depth of label stack nodes can support in your domain.
Right. So this was ACH header was considered. There were various issues which were identified. They are not captured in the draft. I will send you offline. You can review, provide me a rebuttal if you agree or not, and then I think we will capture it in the appendix.
Yeah.
That's the plan.
But okay, so I was already mentioned. So my second question was, sorry to hog the mic. Have you looked at the applicability of this approach to SR-MPLS?
Yes.
Yes, and?
In the first iteration of the draft, it is not captured. It works in the SR-MPLS.
But then you have to allow multiple insertions of this label in the stack.
So in this presentation, I'm not covering SR, but yeah, but it's considered. And there is a packet flow which we will circulate in the next iteration.
Hello, it's Adrian. Can I make a plea to you to take the explicit IONA value out of your draft and replace it with the letters TBD?
I will do that. TBA.
Well, TBA or yeah, TB, anything you like. Because yeah, it's really dangerous putting values in drafts. You've picked one that has been allocated already by IONA for something else.
Realize that, yeah. So this is an example of Mint deployment where an MPLS domain is actively participating in Mint data collection. As you can see, LER has been designated with the Mint initiation and the termination function. And by the way, they are logical functions. Same physical node may be performing both the functions. That confusion happens whenever we talk about it, but this is just a logical representation of the topology. And the transit routers, the LSRs, are the one which are acting as the Mint transit nodes or Mint nodes inserting the metadata. And on the penultimate hop, both the behaviors are supported where we can do the PHP. And in that case, the last hop's metadata actually is not available. Some deployments, it might be okay. Some deployments, it's not okay. And the reason this is being considered is ability to put less stress on the hardware. If hardware has to do the label pops and then the second set of lookups, it becomes very expensive to do the hardware implementation.
Okay. I see a problem. You have like 3-4 minutes left.
I will
And
just
you've
try
done
to-
half your slides, so you have to come to a conclusion.
Yeah, I'll go faster. This is the packet format, and in this case, the CSP is the extension label and the mint label, and then there is the stack of mints which is present. You can go on the text. The tunnel mode is supported. Again, this draft does not go in the details of the tunnel mode, but the basic concept is propagation. Those edits will come in the next set of draft, which is the propagation that whenever a mint packet enters into another tunnel, just like TTL propagation, we can have a configuration which says that propagate the mint information when it enters into the tunnel. What essentially it means that we can enable still a per packet flow, and we will collect the data before it enters into the tunnel mode, in the tunnel itself, and when it transits the tunnel, then also the data is collected. So that's the tunnel mode. In the transport mode, there is only a single stack which is present, and again, this is to ease the implementation, that if there are some hardware limitations where it's very expensive to support two modes, then the tunnel mode, then transport mode may be a good idea. I'll just quickly go over the header before so that my time is close. This is the header, and in this, if you see, by the way, here I use TBA, but in the draft we ended up using actually a label. So there are two headers. One is a mint header, which has the control information, and this header influences the behavior of the packet in the data path. It tells what to do, what not to do. Then there is a metadata header. It has no control information. It does not control the behavior of the packet. All it has that what's the length of the metadata, what kind of metadata to collect. Is there a need to take an action on the metadata itself? Let's say we do some kind of thresholding, and what is the current length? There are some implicit checks which can be done, use this information, which sort of functions like a control function, but they're really not a control function. And the reason I'm bringing it in the IPPM working group, the other proposals ended up putting a lot of information in the mint metadata header, and there was a feedback that really breaks the paradigm of the layering of the header information.
You're running out of time. You have like 1 minute left.
Okay, so next protocol field is the one which can be used to create a chain, and this is something very, very interesting because when you put the mint header, then you can actually indicate what kind of payload is carrying. I'm going to stop here. The next steps is that we are looking for review and comments on the draft.
Sorry, so can you go a couple of slides back to the tunnel mode? Yeah, so I understand that the ingress you add or copy the mint label, the overlay. So what happens in the egress? When there's a transit tunnel, and if you want to decapsulate and send it out, and if you have data in the mint at the outer layer, what do you intend to do?
So that's a very good question. Yeah. So there are two ways we can handle it. We can reflect it back into the inner mint stack, and that's how that mint data can be carried. And it may be okay for the flexible NPUs, which can do much more flexible processing of the data, but fixed pipelines, it's not okay. There is a mode which is supported, which is called a fragment. In that case, we can take this data along with the packets, send it out to the collector instead of reflecting it back into the inner.
Okay, it's not a question.
Greg, crisp and clear.
Yes.
Like 30 seconds.
Yeah, I strongly encourage you to read hybrid two-step and IFA drafts. A lot of similarities and then being around. So let's think how can we work together.
Okay, so we have to finish here. Thank you very much. We take this to the list, and I expect the authors actually to be pushing discussion on the list.
Hello, everyone. I'm Xiaomi from ZTE. I'm going to present draft 10 MPLS in-band PM encapsulation. This is a 0.0 version draft. Okay, intention of this draft. This draft defines the encapsulation for MPLS in-band performance measurement. This method is based on RFC 8321 alternate marking method. This method requires MPLS flow identification, which is discussed in RFC 8372. And synonymous flow label is a way to do this flow identification. But it's a bit complex to manage, and it seems not applicable to nested flow ID. So this draft applies a special purpose label. This slide demonstrates the in-band PM encapsulation. It requests in-band PM indicator label. It's a special purpose label. And it's followed by a flow ID label that includes 20 bits flow ID values, 1 bit loss marking, 1 bit delay marking, and all these fields are required by RFC 8321 alternate marking method. This is the first example to illustrate the scenario how flow ID label can be applied to LSP. In this example, you can see flow ID label is not at the bottom of the label stack, and the PW label or VRF label are at the bottom of the label stack. This is the second example to illustrate the scenario. Flow ID label is at the bottom of the label stack. In this scenario, it can be used to measure the PW or VRF. So that's a different example with the previous one. This is the third example. In this scenario, nested flow ID exists in the label stack. So it can be used, can be applied to LSP as well as PW or VRF. So among the two flow ID label, one is at the bottom of the label stack, and another one is not at the bottom. Okay, next step, ask for review, revise the draft, and then ask for working group adoption. Any question, comments?
Any questions? Okay, so we are at the end of agenda. Thank you. And you need to take this to the list, and actually authors need to push the discussion on the list. So
okay. I initiated the discussion on the list. Thank you.
So we concluded the meeting. Next time is where? Montreal. Going back to, so we started this kind of thing where we're going back to the same city for a second or third or fourth time. So Montreal is a place we've been before. I don't know if it's the same hotel, but I remember it's a good place. So see you there. Safe trips. Yes. No, that's correct. Yeah, I didn't understand. That's why I'm kind of trying to clarify the question. Yeah.
So I sent you response trying to explain the motivation for the slides.